Okay, I wanted to make a quick video here to make sure that everybody was sort of able to at least get started on this homework. I realized today in lab that some of you guys probably need a little bit more information so that you don't get stuck on syntax. And so basically what I've done is I'm trying to create this video here so that we can all get on the same sheet of music. Okay, what we have here is the same graph that you have at the end of the last lecture notes, and each method that's part of the homework. We have right here is the bisection routine, and this is what I'll show you today. Basically what we do is if we have a function, say some function f of x, and it crosses the x-axis here, okay, right here. Here is where f of x is equal to 0. So that's the root finding problem. And so to try to solve this problem with a bisection routine, what we basically do is we select the root here, xr, and it's xl plus xu over 2. So that's just the upper limit plus the lower limit over 2, and that gives us some value here. This is xr, this would be xu, and this would be xl. Okay, so obviously the root, the actual root here, is to the left of it. Okay, so the root is actually right here. And let me get a different color so you can see. Okay, where the function crosses, it's actually about right there. Okay, but the xr that we've gotten is to the right of it. And so what we want to do is we want to see which interval the root is inside. Okay, we want to know is the root on this interval from xr to xu, this interval, or is it in this interval from xl to xr over here? And so what we do is we basically test, and we say if f of xl times f of xr is less than 0, then we make xu equal to our xr. Okay, so what that basically does is it moves our upper limit. And so in this case, we have f of xl, which is this one, and this f of x here is going to give us this value. Okay, this is f of xl. That's going to give us a negative number. Then we have f of xr here, okay, which is this number right here, and that's going to give us this value right here, f of xr. And I know this is a little sloppy, so let me just rewrite these in a place that's a little bit easier to see. So I'm going to drag this down if I can. I don't know if I can. So I'm going to drag this down to here and just rewrite that. So again, this is a bisection method. Okay, we have some function. Okay, it comes here, and we pick some value right here as xu, some value here as xl. Then according to this formula here, we calculate xr, and in this case it'll be somewhere like right here. Okay, so obviously f of xu is going to be this value, and f of xl is going to be this value, and f of xl is less than 0. F of xu is greater than 0 because this is below the y-axis. This is above this is below the x-axis. This is above the x-axis. Okay, so we basically just test. We say that if f of xl times f of xr, okay, and again this is going to be your f of xr right here. Okay, this is f of xr. we say if f of xl, which is this value, times f of xr is less than 0, okay, that's what this first line says here, then xu is equal to xr. So what we basically do is we're testing to see if where the root is. Is it in this interval up here, or is it in this interval down here? Is it between xl and xr, or xr and xu? Well, because there's a sign change, we know that the root is over here. Okay, and that makes sense because this is positive, this is negative, it's going to give us a negative number, and both of these are positive. So then here we say that xu now becomes xr. Okay, so the next time through the loop, what we'll do is we cross this off, this xr, and he becomes xu. Then we calculate another root here, which is xr, and then we test the interval again. And here we're going to get an f of xr that's right here, and an f of xl that's here, and an f of xu. Now, f of xu that's here. And then we again test f of xl times f of xr. If it's less than 0, then we say that xu is equal to xr. But in this case, it's not. Here, they're both negative, okay? So we get a positive number. If f of xl times f of xr, which is, if it's greater than 0, then xl becomes xr, okay? So then what we do here is we now say that this becomes our new xl for the next time through the loop, and this becomes our new xr. So that's the process that we're doing. So now let's talk about how do we actually implement that in MathCAD.